So I've been working on trying to implement a floppy disk drive into Sol-1, my homebrew mini computer here. As you can see, I have a dual floppy disk drive here. It's turned on at the moment. These are 5¼ inch drives. They have these little latches at the front, and you pull the disk out like this. So these are quite old school. They used to be called mini floppy disks. So yeah, they're 5¼ inch. And this one in particular is 160 kilobytes. So it's a single-sided disk, so you can only use one side. And this one in particular holds 160 kilobytes. That's on the one side. And these floppy drives here, they also have a single head each. Later ones they had 2 heads each. So there's this little spring mechanism here. This is just to hold the disk in place, and underneath there's a magnetic head to read and write. Here in the center there's a motor that turns the disk. Here's the stepper motor that will move this head forwards and back to find the track. So I think this disk has 40 tracks total. This is the power supply. It takes ground, 12 volts and 5 volts. And then you have the data cable here, which is 34-pin ITC cable. So here's Sol-1, my computer. I have an oscilloscope right here that I was monitoring the circuit with. So I'm working on this test circuit here. So in order to control the floppy drives, you need a floppy disk controller. So I am experimenting, and I have chosen to use this controller, which is the WD1770, made by Western Digital. It's one of the simplest floppy disk drives, one of the earliest, but I was attracted to it because the later ones, they're more complicated, and I didn't need all the features that they had. They just make the design more and more complicated. And this one just gets to the point. It has all the basic features that I would need, like formatting the disk. It has writes precompensation. You can read, write, you can seek, and everything. You can do everything, all the basics. And you can also select whether you want to use the drive in single density mode or double density mode. So the way it's set up here is I have the controller there. There's an 8 megahertz crystal oscillator that the chip requires. Here I have an open collector inverter, well, a set of inverters, but they're open collectors, so they can sink current, but they can't source current. That's a requirement by the floppy drives, because these floppy drives, in the data cable going into here, they have a termination resistor here, which I have removed for now, but those are termination resistors, which are also pull-up resistors, so they will pull some of the lines high if they're open. So that's why I use open collectors in there. I have a resistor here to pull up some of the output signals of the controller. Not the output signals, I mean the input signals. Because again, some of the outputs of the drive are open collector, so we need to pull up some of the pins in there. And then here is just the signals going into the ITC cable, like that. And if I show you here, maybe what the chip looks like, the controller. So I'm sure you can read this. So this is the WD1770, and you can see the pin out. We have the chip select on the left, pin number 1. We have read write, so that selects whether you're reading or writing. So you set that, so writing is 0 and reading is 1. And then you pull load the chip select. So if you're reading, it will output data into the data bus, and if you're writing, it will latch the data from the data bus. Here is 0 and 1 A1, you have the address of this register that you want to select. There are 4 registers in there. So register 0 is the status register, register 1 is the track register, register 2 is sector register, and register 3 is the data register. So for example, if you want to seek to a certain track in the disk, you put the track number into the data register, and the floppy drive will use that to set the track. So on the left here you have the data bus from 0 to 7, so it's 8 bits. Reset, ground, power, 5 volts. This is the step line. So here's where we get into the signals that go into the floppy drive. So this is a standard floppy drive interface. So you have the step signal. For the floppy drive, when the step goes low, the floppy drive will move the head by 1 position according to the direction flag. So if the direction in this case is high, then the head will move towards the center of the disk, and if it's low, it will move towards the edge of the disk. So that's what those two do. Then you have the clock input, which is the 8 megahertz. Then you have this read line, which is an input. This is the data coming from the floppy drive. Then the next one up is motor on. So that signal tells the drive to turn on the motor. Up you have write gate. That will determine whether the floppy drive will or will not write the data at the WD output there, as you can see. The WD output is the data that the floppy drive controller is sending to the floppy drive. Then we have the track 0 signal. That signal is an output from the drive that tells if the head is at track 0. Next up we have the index pointer. That is the so these floppy drives, if I show you here, they have this index hole here. So this disk inside also has a little hole. So when that little hole passes through this hole, then the floppy drive knows that we are at sector 0. So this is for a sector 0 marker, and this IP is that whenever the head, whenever the index hole passes over the head, that will go active low. Then we have the write protect input to the controller that tells if the disk is write protected. Next up is the double density pin that tells the controller whether we are operating single density or double density. Next up is the DRQ or data request. So let's say you issue a command to either write or read from the disk. Whenever the disk drive fetches or writes a byte into the disk, that will raise this line high. It's a request, data request. So for each byte that the floppy drive reads, this data request line tells the CPU that the byte is ready and the CPU can read it. And then next up is the interrupt. That's an output of the controller for whenever a command is executed by the controller. It will raise that line high and will pulse it, so the CPU knows that the command is finished. So here we have the description of all the signals. And so maybe I should give a quick demonstration of the drive here. So you can see it stopped. Here I have on the breadboard everything connected. So if I find the motor on jumper here, which is this one, at the moment the motor is not running, so the signal is high. So if I pull this signal low here, like that, you can see the motor is running now. You can hear it, but you can even see the disc wiggling there. But yeah, so the motor is on. So that's the motor on signal. It controls the motor. Let me turn it off here right now. So now I'll show you a quick demonstration of a command being executed. So first thing I'm gonna do is so now you can see that the head is at track 0 at the moment. So I'm gonna turn off the drive and come here. I'm gonna move the heads manually here to the end, middle of the disk. Now I'm gonna turn the drive back on. The drive just tests the little motor there. And now what I'm gonna do is I'm gonna send the command to move the head back to track 0. So that command is command number 0. So if all the data lines are 0, then so this is address 0, which is the status register when you read, and the command register when you write. So that's address 00. Here's the read write, which is 0 for writing. This is the chip select, which is high right now. So I'm gonna post it low, and when I post it low, you see the head will move back to track 0. So here it goes. Yeah, like that. So that was the restore command. So yeah, it restores the head back to track 0. There are other commands like step in, step out, read data, write data, read sector, write sector, and so on. So yeah, so I'm working on it right now, and just gonna finish doing some tests. And after that, I'm gonna wire it up into Sol-1, my homebrew mini computer, and then we'll go from there. It's been a long time. I have wanted to add a floppy drive to Sol-1, but I never really got to it. But yeah, it's happening now, so I'll let you know when I have made some more progress. But yeah, for now, thank you so much for watching. I hope you have enjoyed it. Bye.